So in this lesson we'll talk about more ways of describing functions, and we'll just talk about when is the function increasing, decreasing. We'll talk about the high points and low points called the relative extrema, and also something called average rate of change. So if you want to copy these, pause the video and copy these. Identify the intervals of increase, decrease, and constant values. So an interval of increase, we want to make sure that we don't just look at the arrows and we say that's going down, so it's decreasing, and that's increasing. You should ignore the arrows and just follow the graph from left to right. So that's increasing, constant, increasing. And then the confusing part can be that you have to describe the x values where it's increasing. So sometimes you look at it and you look at the y values, but we really want to describe the x values where it's increasing. So this is increasing from negative infinity to negative 1. And when we talk about intervals of increase and decrease, we'll always use parentheses. We won't use the brackets. And then it goes constant, constant from negative 1 to 1. And then it'll increase again from 1 to infinity. Increase. All right. Then looking at this one, make sure we don't see that arrow as increase, because we just followed the graph. That's decreasing, increasing, decreasing, increasing. So it's increasing from negative infinity to 0. I'm sorry, that's decreasing. It's decreasing from negative infinity to 0, and then it increases from 0 to 1. Decreases from 1 to 2, decreases from 1 to 2, and then it will increase from 2 to infinity. Alright, pause the video and try the next two. So here, this does not say increasing, it says decreasing. We're going to decrease from negative infinity to negative 1. Then it's going to be constant from negative 1 to 1, and increase from 1 to infinity. Here we'll have decrease from negative infinity to negative 2. Even though the arrow points up, we read it from left to right. It's decreasing and then increasing from negative 2 to 0. And then we go decrease from 0 to 2, decrease 0 to 2, and this looks like it's constant from 2 to infinity. So remember, all these intervals are x intervals. We don't look at what the y values are for increase and decrease. Need the graph. Alright, so we can estimate the relative maximum and relative minimum. Those are called relative extrema, and that's the extreme value, meaning a high value or a low value. And then we'll support it with a table. So, relative maximum. The maximum appears to be um, hmm, um, this was supposed to be a little bit over further beyond 1. So here's 1, here's the maximum. Here's -1, and then the minimum is a little further over. So we're going to estimate that that is about 1.3. And it looks like the y value is 3. We don't know if that's correct because we're just reading the graph. And then we'll look for the, let's test the maximum. So if we're going to test the maximum, let's look at x values on either side of 1.3. So at 1.3 we get 2.878, 1.4 we get 2.854, and 2.696. So does it look like this is a maximum at 1.3? Looks like we got this wrong from the graph. The actual y value is 2.878. Choose numbers on either side. If these numbers on either side have lower y values than this, then this could be the maximum. We don't know for sure, but we have support that it's the maximum. So 2.85, 2.87, well that's higher than that, and that's higher than that. So now we've shown support that the maximum is at 1.3, or near 1.3. Then we'll look for the relative minimum. So look back at the graph. Negative 1.3 approximately, down 3. Negative 1.3, negative 3, question mark, and then we will test that by using x values on either side of negative 1.3. And we can choose negative 1.2, negative 1.4. Let's see what we get. Negative 2.878, negative 2.696, negative 2.854, just the reflection of the other y values, and it looks like we have the lowest out of these three, that is the lowest y value, so that's support that the minimum is near negative 1.3. Alright, so estimate the minimum and maximum here. Pause the video and try that. So it looks like 0, 0 is the minimum, and 1, 2, 3, 4, 5, 6, it looks like the maximum is at negative 6. So relative minimum, is that going to be 0, 0? We don't know, so we'll test it. We'll go to either side. Let's go to 0.2 and negative 0.2. The y value is 0. And here we have 0.0125, 0.014. If we're going to say that's a minimum, we want the y value to be lower than the numbers on either side, and it is. So that's support that we have a relative minimum there. The maximum looks like it's at negative 6, negative 12. So we're going to test negative 6. Let's go to the right of negative 6, negative 5.5, negative 6.5. You may have chosen different x values to test, and the closer you get, the better. So I have these on this one, but it's still showing support that this is having the highest point out of these three. It is the highest y value. So we'll say that that is the maximum. All right, we're at -2, somewhere beyond -2, and then down beyond 7. 1, 2, 3, 4, 5, 6, 7. So beyond -2, beyond -7, that looks like that's where the minimum is. And so test that. Choose an x value where you think the minimum is, and the maximum is pretty obvious. But pause the video and test that. All right, the minimum looks like it's beyond -2, so we'll just say -2.7. And how far down does it go? We'll just say -7.5. It's somewhere beyond -7. Then we test. We have to go on either side of -2.7, and we have -7.464, -7.477, -7.408. All right, we say it's a minimum, so it needs to be the lowest point. -747 is lower than -746, and here we have 740, so that is the lowest value out of these three, and that support that there's a minimum there. Okay, the maximum looks like it's at 0.2, so then we test on either side of 0, and we'll go to 0.1, -0.1. When we substitute a 0, we get 2, and here we have 1.959, 1.961. So it looks like that is the highest value out of these three, and it looks like it's going to be a maximum. So that's increase, decrease, and then relative extrema. The last thing we're going to do is average rate of change. And rate of change is another phrase for slope. We're not going to find the slope of every graph. That is going to be in calculus, and here we're just going to find the average rate of change of a graph. So and then we're going to go over 2 up 4, and this is x squared. So we have a parabola, and if we looked at the slope right at that point, that's called the instantaneous rate of change. And we'll do that in calculus. But today we're going to do this, where if we had 2 points and we just draw a line through them, then the slope of that is the average rate of change. The slope of that red line is and that's all we're going to do is find the slope of that line. It's called a secant line. This is called a tangent line, and that's called a secant line. Alright, and here's, we don't have to show all this work every time, but we know slope is y2 minus y1 over x2 minus x1. And if we write instead of a y, we'll say g of x2 minus g of x1 over x2 minus x1. And here we have the x values of -1 and 3. So we're going to do g minus g over, and this says x2, but we could put the 3 first or the 1 first, it wouldn't matter. 3 minus -1, and we have -4. 3 squared plus 3 times 3 minus 4. Putting the 3 into g. Now let's put the -1 in. -1. And if we evaluate that, we have a y value minus a y value, x minus x, and that's just the slope formula. We're finding the slope of a secant line. And we say the slope is, the average rate of change is -5. Okay, pause the video and try that one. So we have f of 12 minus f of 5 over 12 minus 5. And now we'll just put a 12 into that. 12 minus 3 over 12. And then we'll do 5 minus 3 over 5. 12 minus 5. So 9 over 12. We have 2 over 5. We'll have to make that a 60, so we'll multiply by 5 over 5. 12 over 12. 45 minus 24. Put this 7 up as a fraction. So now we have 21 over 60. And reduce the 21 and the 7. 3 over 60, or 1 over 20. And we'll stop there on that lesson.